Okay, so let's get into it. We're gonna build an Arduino traffic light. Yeah, it's a classic beginner project, I know. But here's the twist. We're not just gonna blink some lights. We are gonna build this thing using a pro-level coding technique that really unlocks what your Arduino can do, and we're gonna leave those bad beginner habits in the dust for good. So here's the game plan. First, we're gonna talk about the big hidden problem with the delay function and why it freezes so many projects. Then, we'll roll up our sleeves and actually build the circuit. After that, we'll dive into the much smarter, non-blocking code. Of course, we'll cover the usual troubleshooting stuff, and then at the end, we'll look at where you can take this awesome new skill. All right, let's kick things off with the single biggest hurdle for anyone starting with Arduino. I'm talking about that sneaky, deceptively simple delay command. You know the feeling, right? You upload your code, a light turns on, and then nothing. For a few seconds, the entire board is just a paperweight. You can't press a button, you can't check a sensor, it's totally stuck. Well, that's exactly the problem we're here to fix. And this really gets to the heart of it. See, using delaying is what's called blocking code. It literally tells the Arduino's brain, hey, stop everything you're doing, just sit there and count. In total contrast, the millis function lets us write non-blocking code. With this method, the Arduino just takes a super quick glance at its internal clock and asks, hey, is it time to do the thing yet? And then immediately gets back to its main loop, totally free to handle anything else you throw it at. And this quote just sums it up perfectly. Yeah, delay technically works, but it freezes the board solid. The second you want to build something even a little bit more interesting, something interactive, that delay function suddenly becomes your #1 enemy. Okay, enough with the theory. Let's get our hands dirty. It's time to grab our components and actually build this thing. So for this build, you just need the essentials. Go grab your Arduino Uno, a breadboard, your 3 LEDs, red, yellow, and green of course, a handful of jumper wires, and 3 220 ohm resistors. Those are crucial for keeping our LEDs safe. First up, let's take the red LED. Just pop it onto the breadboard. Now pay really close attention here. One leg is longer than the other. That long leg is the positive side, the anode. Getting this right is absolutely key. Next, grab one of your 220 ohm resistors. You're going to connect it to the same row as that longer positive leg. This little guy is what limits the current so we don't accidentally fry our LED. And now, you guessed it, we just do that all over again. Place your yellow LED on the board, again watch for that longer positive leg, and connect its own resistor. And one last time for the green LED. Pop it into the breadboard and connect that final 220 ohm resistor to its positive leg. Simple as that. And would you look at that? Once you get your jumper wires connected from the resistors to the digital pins on your Arduino and run the short legs of the LEDs to ground, your circuit is officially complete. It's looking good. Now, for the real magic, the code that's going to bring it to life. All right, this is where we really level up. We're going to stop thinking in terms of clumsy delays and start thinking like a real control system by using time itself. So let's just take one last look at the bad old way, right? Turn the green light on, then stop. The whole program freezes for 5 seconds. Turn the yellow light on, stop, again for 2 seconds. You can literally see where the project just grinds to a halt. We can do so much better. Now, the professional way to handle this is with something called a state machine. I know it sounds super complicated, but it's actually really simple. All it means is that our program can only be in one specific state at any given moment. So it's either in the green light state or the yellow light state or the red light state. It then switches or transitions between these states when something happens, in our case, when enough time has passed. So how does this actually play out in the code? Well, on every single pass of the main loop, and remember this is happening thousands of times a second, it does this really quick check. First, it grabs the current time. Then it asks itself, hey, have I been in the green state for 5 seconds yet? If the answer is no, it just moves on and the loop keeps running. If the answer is yes, it switches over to the yellow state and makes a quick note of the time it made the switch. The key thing here is that the loop never ever stops. It's always running, always ready. All right, let's talk about maybe the most important part of any project, troubleshooting. Because let's be real, we have all had that moment. You're sure you did everything right, you hit upload, and crickets. Nothing happens. Let's figure out how to fix that. Okay, first problem, and it's probably the most common hardware issue. You've wired everything up. The Arduino's power light is on, but one or all of your traffic lights are dark. What's going on? Here's your rapid fire checklist. Number 1. Is the LED in backwards? Remember that long leg has to be pointing toward the digital pin. Number 2, trace your circuit. Follow the wire from the Arduino pin, through the resistor, through the LED, and back to the ground pin. Is there a wire loose? Number 3, double-check your code. Does the pin number you wrote in your code actually match the pin you plugged the wire into? And finally, check your resistor. A 220 ohm should have red, brown color bands. Okay, now for the other big headache. You hit that upload arrow and you're immediately greeted by a terrifying wall of angry red error text at the bottom of the screen. Don't panic. This is usually an easy fix. So let's break down the most common ones. If you see an error about no upload port, the number one culprit is a cheap USB cable that only carries power, not data. Seriously, try a different cable. If you get programmer not responding, just pop open the Tools menu and make sure you've selected Arduino Uno as your board. And for that dreaded compilation error, 99% of the time, it's just a typo. And the most common typo of all? A missing semicolon at the end of a line. Okay, we're in the home stretch. So, you've built a responsive, smart, non-blocking traffic light. You've learned a seriously powerful new way to code. So the big question is, where do you go from here? Well, this skill just blows the doors open for bigger projects. How about adding a pedestrian crosswalk button? Since your code never freezes, checking for a button press is now super easy. Or you could try programming a British-style traffic light. They add a red and yellow phase to tell drivers to get ready to go. Or, if you're feeling really ambitious, why not expand this to control a whole four-way intersection? And this really brings us to the big idea at the end of all this. The technique you just learned, it isn't just for traffic lights. I mean, think about it. Your microwave oven, the dashboard in your car, critical medical equipment, the control systems in a factory. All of these things have to juggle precise timing and multiple inputs, and they can absolutely positively never just freeze up. What you've learned here today is a fundamental building block of real-world engineering. Now, what are you going to build with it?